All right, we're doing the review for section 2.1, which was quadratics. Okay, we're going to start with number 5. The instructions ask you to find the quadratic function and to write the quadratic function in standard form, but remember we discussed when the book says standard form, it actually is wanting vertex form. Okay, so first of all, just as a reminder, vertex form is y equals a times x minus h squared plus k, where your vertex is hk. To do this, to get from, this is what we were calling standard form. To get from standard form to vertex form, we have to complete the square. Okay, you factor out an a. I don't have an a, it's an understood one, so there is nothing to factor out. Okay, so I just have x squared plus 8x. Remember, after your linear term is plus box, your constant is on the outside, minus box. To get what goes in that box, you take half of b and square it. So our b is 8, divided by 2 is 4, squared is 16. If there was something outside factored, you would multiply. There is nothing, so 16 also goes in the minus box. When you simplify this to clean up how it's written, remember it's x and then plus or minus whatever half of b was. So half of b was 4 and it was positive, so it's plus 4 squared, and on the outside you can combine like terms, which is minus 6. Okay, so this is your answer for part for the first question. Write the function in standard form. Okay, before we sketch its graph, we're going to identify this important information because that's how we're going to sketch the graph. The vertex is h, so the opposite of what's in parentheses, so negative 4, k, negative 6. That means my axis of symmetry is x equals negative 4. So now I can graph this. I'm going to go ahead and put my xy axis on here. And the reason I'm doing it here is because I know that, one, this is in the third quadrant, my vertex. So it's mostly going to be in the third quadrant. So when I go to plot my point for my vertex, negative 4, negative 6. Okay, and from your vertex then, to figure out where you go from there, remember, look at your a. This is an understood 1, so that means it's the same as the parent function, which, if you don't remember, you can write it out. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on and so forth. So that means from your vertex, go over 1, up 1, over 2, up 4. Okay, so here's my vertex, over 1, up 1. Over 2, up 4. Okay, and you would graph this. Okay, we are also asked to find the x-intercepts, however, and I can't plot those yet to know where I'm crossing on the x-axis till I find them. So remember, to find x-intercepts, you factor your original equation. So in standard form, we set it equal to 0. Okay, so if I go to factor this, you will realize that this cannot be factored. 5 and 2 or 10 and 1 will not combine to 8. So when it cannot be factored, you use quadratic formula, which we covered in class today. Quadratic formula, remember, if you sing the song, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Identify your a, b, and c. So my a is a 1, b is 8, and c is 10. So when I go to plug all of that in, negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 10 all over 2 times 1. Okay, so I'm going to come off to the side over here and simplify what's under the radical. Okay, 8 squared minus 4 times 1 times 10. 8 squared is 64. 4 times 1 is 4, times 10 is 40, which leaves you with 24. So under the square root, I have 24. This is not a perfect square. I cannot take the square root of it, but I can simplify with my factor tree. Okay, so any two factors of 24, you could just go 2 and 12, and then 12 can keep going. And any pairs you have get to come out. So there's a pair of 2's, so a 2 gets to come outside, but this 2 does not have a pair, and this 3 does not have a pair, so they stay inside. So 2 times 3 is 6. So the square root of 24 simplifies to the 2 times the square root of 6. So when I write this, I have negative 8 plus or minus 2 square root of 6, and this is all over 2 times 1, which is 2. Okay, and we said we need to simplify our fractions. Both of these terms are divisible by 2. So if I split them, I can reduce these fractions. Okay, so this reduces to negative 4. Negative 8 divided by 2 is negative 4. Plus or minus. The 2 divided by 2 cancels, and you just have square root of 6. So this is what x equals. Those are your roots, or your x-intercepts, or solutions. If you're not sure what that is as a decimal, like where to plot that on your graph, you can type this into your calculator. Let me pull up the calculator real quick. But if you type this into your calculator, we have negative 4 plus the square root of 6. That's about where it should be. It should be between negative 1 and negative 2. So about at negative 1 and a half. Okay, and then we have negative 4 minus square root of 6. And that's at about negative 6 and a half. So when you go to plot these, you're not going to be able to plot them exactly because they're irrational numbers. So we go back. I'll take a capture of this so it's on the screen. Okay, and these are the roots we're plotting right here. So on your graph, about negative 1 and a half. So about right here, and about at negative 6 and a half. About right here. And if you can see, that's pretty accurate. If you got something way off that your sketch so far, there's no way it could go through it, you should realize you have made a mistake. Okay, so that's a good way to check yourself. And then you can hopefully draw a little better than me. Okay, you're not quite done. I told you when you're graphing quadratics, you need to have that axis of symmetry. So you need to use a dotted line to represent that axis of symmetry. And then you are done. Alright, this is still section 2.1. These are the last few on that section of the review. In 15 and 16 and 17, you're asked to write the standard form of the equation. Okay, that means vertex form because our book is stupid. Vertex form. Okay, of the parabola that has the indicated vertex and whose graph passes through the given points. Okay, so first of all, you need to know vertex form. Remember, it's a times x minus h squared plus k. Okay, and your vertex is hk. It's the opposite of what's in parentheses and then what's on the outside. So we're given the vertex, so that means 4 is h, 1 is k. And then you're checking with that second point to see what is a. Is a just 1? Is it positive? Is it negative? or has it stretched or shrunk our graph? Okay, so we're going to look how many over and down we moved. So we were at 4, and we go over 2, down 2. Okay, normally in our graphs, I'm going to put the parent function table here just as a reminder. Normally when you go over 2, you go down 4. So we're going half of that. So our A is taking half. Okay, so A is half. And notice we went over and down, okay, instead of up. So that means it's negative. So our A is negative half. So this equation would be y equals negative half times x minus 4, because remember it's the opposite, plus 1. Okay, for number 16, your vertex is 2, 2. So your H and K are both 2. Then you're checking the movement from your vertex. We go over and up. So we know it's positive because we go up. And we went over 2, up 1. Normally when we go over 2, we go up 4. Okay? So we're only going up 1. That's a fourth of the way. So A is 1/4. And it's positive. So your equation is y equals 1/4 x minus 2 squared plus 2. Okay? And then we're going to look at 17. Instead of giving it to you on a graph, they're just giving you the points. So this is our H and K. Now, if you can't visualize it in your head, go ahead and draw out the points. Okay, so I'll give you a quick little grid here to refer to. If we are at 1, -4 is our vertex, and it goes through the point 2, -3. From your vertex to that point, you went over 1, up 1. That's what you do in the parent function, so A is just 1. So your equation is y equals x minus 1 squared minus 4. Okay, and that's the end of section 2.1.